and Patricia Arean, and she has worked for the last part of her career in the University of California in San Francisco, but recently she moved to the University of Washington in Seattle, where she became a full professor of clinical psychology. And she has published several articles on the recognition and treatment of late-life depression, and especially in minorities and elderly with mild cognitive problems. And she has also been a psychotherapy expert for some big trials in the United States, like the IMPACT trial and the PRISMATE trial. But she's invited here because I loved her work on the problem-solving treatment with depressed elderly people with executive dysfunctioning, and especially also in this patient group, she's always trying now very innovative interventions with video gaming. So I think there are new avenues for our field. So it is my great pleasure to give the floor to you.
Thank you. I'm very pleased to be here, and I love the Netherlands. I've been here before, and so when I was invited, I said yes immediately. I didn't even think about like whether or not I had something else. I would have canceled. So just to start off, I want to just acknowledge that I don't have any conflicts of interest. My university appointment is a public state university, both times in California and in Seattle. So I'm not funded by private institutions. I don't receive money from private industry, even though some of what I'm going to be talking about today are interventions that are developed by game companies, but they don't pay me to do the research. So what I'm going to be talking about is basically talking about executive control and treatment response. I'm going to give a little overview around how some of the work that my colleagues at Cornell University have done to identify older adults who are at high risk for not responding to antidepressant medication. And then what I'm going to do is to talk about some of the recent developments in the United States around how we've been thinking of designing targeted treatments based on these risk factors that we've been able to identify in depression. Then I'm going to talk about 3 projects, one which is completed and the data have already been published, and then 2 others that are in process, but we have some preliminary data to share. Okay? So, we've been hearing a lot today about cognitive impairment and late-life depression, and some of the common cognitive factors that are associated with late-life depression are things like reduced information processing speed, reduced working memory, and then also reduced response inhibition and selective attention. So there's an awful lot of research looking at the cognitive correlates of depression in late life. Executive impairments are probably the most common, and they tend to be the most problematic in treatment response. So my colleagues at Cornell University, and this data had been replicated by other universities like the University of Pittsburgh, so Merrill Butters has done some of this work, as well as Yvette Shaleen at Washington University in St. Louis, so not to confuse with where I am at. But basically, George Alexopoulos is sort of the leader in this field, and he was able to identify early on that older adults who had a poor response to SSRI medications, particularly medications like citalopram, tended to have a very consistent clinical presentation. They presented with an awful lot of apathy, difficulty getting started, initiating tasks, poor decision making, and to some degree some impulsivity around their decision making. So we kind of saw this really common clinical presentation that he later was able to identify as this distinct cognitive dysfunction in the brain. And so just to kind of explain how the executive network works, just really quickly, a little brain exploration. There are sort of 2 vital regions in the brain that control our behavior. So there's the ventrolateral prefrontal cortex and the dorsolateral prefrontal cortex are really involved in helping us make decisions. So the best way to sort of explain it is that, your frontal lobes, particularly this area of the brain, are really responsible for things like helping you make decisions around goal-directed behavior. So let's say, for instance, you're really hungry. You'll get some information from different parts of the brain telling you that you're hungry and it's time to do, and what happens is that signal gets processed through the anterior cingulate. so the anterior cingulate says, oh my gosh, we're hungry and we've got to do something about it, and it sort of alerts the frontal lobes, to say, go get me some food. Now, if you didn't have frontal lobes, right, you might do something silly like run across the street, to the hot dog stand, regardless of whether or not there's traffic in the road. But what happens with the prefrontal cortex is it actually surveys the environment, figures out if there are other threat cues in the environment, and comes up with a plan of action to help you actually safely get to the hot dog cart and get something to eat. So in terms of how this works with mood, the signals that the anterior cingulate processes have to do with affect. So in the amygdala, you'll have, maybe there's some scanning going on, and you'll see an older person might see a friend of theirs in the nursing home, and that friend ignores them. And suddenly the anterior cingulate says, oh, there's something wrong. The facial expression of my friend, the fact that they didn't say hello to me, and then, pulling information from the amygdala, from the hippocampus around, memory stores around what this means, would send sort of a signal to the prefrontal cortex about what you should do. And if you're depressed, you might be kind of inhibited. You might be paying too much attention to those threat cues about the fact that this person may look angry. You may misinterpret, that information. Or if you have a fairly healthy brain, it might say, well, there's a couple of different things we could do. We could go up to your friend and ask, is anything wrong? So it kind of comes up with a plan of action to help you with whatever goal that you may have. In studying this particular neural network, what my colleagues at Cornell have found is that it's dysfunction or poor functional connectivity in these regions that is very much associated with poor response to antidepressant medication. So this is important. Why? In the United States, we are now, if a clinical trialist like me, we have to respond to this particular kind of funding mechanism called the Research Domain Criteria Project. And basically the theory behind this is that there is a lot of variability within diagnoses. So in other words, there are a lot of different kinds of major depression. And those of you who are clinicians probably would know, say, I've known that for a long time. I didn't need, the federal government to tell me that there are different types of depression. Some people with depression, have a lot of affect regulation difficulties. They cry easily, they get anxious easily. Other people with depression might be, very negative, have a tendency that no matter what they do, everything is sort of we call it the glass half empty, paying attention to the bad stuff and not the good stuff. And then there are people like the people that George studies who are really more executively impaired. They're very disorganized. They have a hard time making decisions. And so if we can kind of understand these variations in depression and what's causing them, then we can come up with targeted treatments. And so it's a real kind of neat opportunity to streamline our interventions, potentially make them a little bit more effective than they are currently. So maybe we can see more numbers needed to treat, like 2, like Pim was talking about, rather than 7. And we have the potential for making treatment happen a lot faster. So my colleague at Cornell had actually approached me prior to this project and had explained this executive dysfunction, presentation to me. At the time, I was not really that familiar with neuroscience, and so George Alexopoulos had to train me a lot around understanding this particular presentation of depression, and he had read some of my work on problem-solving therapy, had read the manual, and basically said, this is an interesting intervention because there's a lot in problem-solving therapy that's very executive. It helps people, focus their attention on one problem at a time. It helps them come up with an action plan, really forcing them to engage in goal-directed behavior. Do you think this is something that would be effective for, older adults who have dysfunction in this area? And so we, basically looked in the literature, and we found that problem-solving therapy actually can be pretty effective for other disorders where there is executive dysfunction. So, for instance, there's some evidence that problem-solving therapy as part of a larger treatment package can be very effective in people with psychosis, and those are people with a lot of executive dysfunction. Likewise, there's some studies showing that problem-solving therapies can be effective for children with attention deficit disorder, another executively impaired population. So we applied to NIH and basically conducted a study where, multi-site study where we randomized 220 older adults with major depression and executive dysfunction. They were randomized to 12 weeks of problem-solving therapy and supportive therapy, and we followed them for 9 months. We looked at depression outcomes, functional outcomes, as well as executive outcomes. And so the data basically are so again, these are the, I'm sorry, duplicated slide. We also looked at suicide as well. So let me just show you a little video that one of my postdocs made to demonstrate what problem-solving therapy is. Okay, and so it starts with this one step where you basically identify a problem that you want to work on. So you make a problem list, and the therapist will say, just pick one of those problems. There's a lot of things going on in your life. Let's do one thing at a time. The next step is to establish a realistic goal, something that you can do between sessions so the patient has immediate success with the intervention, and then you come up with a number of solutions to reach that goal. Okay? Then you evaluate those solutions, basically looking at the pros and cons and how feasible those solutions could be. So the first thing you do is, the advantages of the solution and the disadvantages as well. So you want to be pretty, realistic about the success of it. Based on that, you pick a solution, and then you create an action plan for solving that particular solution or that goal. The patient has to be, the action plan has to be fairly specific. Who are you going to talk to? Where are you going to meet this friend? In this example, and here we have the patient talking to their friend about getting a job. And then they come back to session and they evaluate the outcome. Okay? And, tell you about how successful or not successful the intervention was. And so most of the times, if you solve the problem pretty successfully, patients have a very good outcome. But occasionally we have people come in and it didn't work perfectly. And we tell the patient this is an opportunity to learn from the experience and redefine the problem. The other thing, too, is that during the course of treatment, the patient's expected to solve other problems. So they just don't work on they don't work just on the problems that they talk about in therapy. They can pick other problems from their problem list and independently engage in problem solving. The results have been very positive for this particular intervention. We saw a clear improvement for problem-solving therapy after, even as early as 6 weeks of treatment, even though it's a 12-week intervention, with a number needed to treat of 4. And that's pretty good when you're talking about a population that's already at risk for non-response to treatment. We found improvement in mood, functioning. We've also found improvement in suicidal ideation, and as well as improvement in executive dysfunction. So this is one of these rare studies where we actually saw improvement in cognition over time after treatment response. What's really kind of interesting about this particular response is these are the PHQ-9 scores over the course of treatment. And as you can see, supportive therapy, I don't know if you can see my arrow, yes, was actually pretty effective too, right up until about 6 weeks. And this is where we start to see the separation in favor of problem-solving therapy. And it sort of led us to think, why are we seeing the separation then? I mean, obviously supportive therapy has a lot of benefit for older adults, the opportunity to talk about their problems, and it's an opportunity to minimize social isolation. But what was happening with PST that made it particularly effective? And so we started to think that potentially what was happening is that we were seeing a cognitive conditioning effect of this particular dysfunctional network in the brain. When you think about how any psychotherapy works, it really is about repeating these new skills over and over again, which is very similar to what we see with other types of cognitive remediation strategies, which I'll talk about in a minute. So, basically when you rely on regular rehearsal of skills over an 8 to 12 weeks, of treatment, then it's probably that's why we were seeing this effect, because you don't do that necessarily with supportive therapy. So this led me to move on to think about a bunch of different ways that we could be targeting this particular population. And so one of my colleagues in neurology at UCSF, Adam Ghazali, had published this really cool, groundbreaking paper on cognitive training for building cognitive reserve in older adults. And so the game that he had created was basically based on this dual task. It's a multitasking game. I'll show you what it looks like in a minute. But what he was able to demonstrate was that after 4 weeks of playing this video game, older adults, not only, this is sort of their brain before training, and this is a younger adult's brain, and this is EEG data, so basically where you would see activation of the cognitive control system or the executive system. And then what they found is that not only did older adults improve or have better activation in, based on EEG after multitasking, but it was even better than the younger adults' performance. And then this is what you see with single tasking, which makes them look a little bit more like younger adults, and this is no contact control. So I had gone to Adam to talk more about doing a study to look at functional connectivity of this network using problem-solving therapy. And as we were talking about the network that I was going to be studying, he said, I study the exact same network. It's only I'm studying it for improved cognitive reserve to minimize memory complaints in older adults. And he showed me the game, and I started to think, what would be interesting is to do this study where we could randomize depressed older adults to the game and PST, with the purpose with the PST arm is seeing what we know it's effective for depression, but is it effective for depression because of engagement of this neural network? And then, also look at the game in terms of the fact that we know that it engages the neural network, but does it have an impact on mood? So we are in the process of doing this study. We've recruited 25 of 40 participants with late life depression. They're randomized to problem-solving therapy, and evolution is the game they're using. And we're doing fMRI collected at baseline 4 weeks and 8 weeks, looking at cognitive control features, so regular Stroop, emotional Stroop. And then we're also looking at reward systems because the game is actually fairly entertaining, and there's been some theories that problem-solving therapy has a positive effect on behavioral activation, which is another reward kind of system feature. And so it's a pilot study, so we're only going for 8 weeks in terms of outcome. So the cognitive training session isn't just the game, though, and it's really important because these are people with major depression. And so what we do is a combination of education, support, and training. The patients meet with a therapist for 8 weeks, and this is to control for the time, exposure time for problem-solving therapy. But the first 4 weeks is in cognitive training. They get to take basically the game home with them on iPad minis. And so the first session, what we found is that some older adults are very familiar with iPads. Others are not, and so some of the session is teaching them how to use the iPad and reassuring them that they will not break it, they're not going to do anything bad to the game. If anything happens, it's easy to fix. And then the sessions are really just a check-in. So let me show you the game. There's a little music that goes with this. This is from the company Achilles. And this will wake you up too. So this starts with a threshold. Basically, the patients just kind of do these tasks individually. This is a go-no-go task. And then they do the driving task, and the two tasks together to get what's called a multitasking index. The game is set at the patient's ability level, and as they improve at doing this dual task performance, the game gets harder and harder, but not so hard that it's impossible. The idea is that you're trying to condition this network, and it's a video game. You can go to these different worlds, you earn badges, you actually can get points and dress up your alien. So it's a very cute game. And so what's kind of interesting about it, I know it'd be fun to play, right? It's a little boring, but and so what's interesting is that in the United States, a lot of older adults are already using cognitive training games, and so this started back, I don't know, maybe like 8 years ago. Nintendo had come out with a game called Brain Age, and it was sold and pushed very hard in the U.S. as a way to improve your cognition. And so, and then since then there's been a lot of other products. A very popular one right now is an internet-based training company called Lumosity, and they make a lot of claims about, improving your brain. So, while at first we were thinking, would an older adult play a video game, and we had some concerns about that, we realized very quickly that the older patients who are coming to us are actually very often ask about that. What should I do to improve my cognition? Should I pay for the licensing fee for Lumosity? Should I get brain age? And so they were already kind of interested in this technology. It was very easy to explain to them that I know it looks like a game that your grandchild would play, but it's really meant to condition your brain and give you something fun to do while you're doing that. Okay. So what's also neat is that the company has created a therapist portal. So the patient's playing the game, and the data get ported securely through Wi-Fi. So if a patient has Wi-Fi in the home, and we live in California, so most of them do. But if they don't, they can come to the hospital when they, bring the pad with them, and then it can be automatically ported to the server. And right away, the therapist can take a look at, how adherent the patient was. Did they play every day? Did they have a lot of interruptions? Are they leveling up? Are they getting improvement? And so, therapist spends about 10 to 15 minutes just reviewing gameplay, helping the patient strategize around it, sticking to the practice, asking if they have any side effects. And because we're comparing it to PhD, they have to fill another 20 minutes in support, which the therapists are having a very hard time doing. They say basically the patient's like, no, I'm fine. And, and they're trying to, say, are there other things that you're doing to make yourself feel better? But that doesn't take 20 minutes. So it's interesting. So we, like I said, we're still recruiting, and so far all of the participants randomized to that condition have been able to play and have been showing improvement. And it's been interesting because there's a lot of variability in how quickly people advance. Some people advance right away. Some of them have gone past levels I've never been able to get to. Others are having a harder time, and we deal with that by basically saying it's okay, you don't have to reach all 4 levels to be improved. This is just kind of set at your, where you're at, and any improvement is good. These are the data so far, and the PST arm, it should be really, clear that that's not the PST condition currently in the study. It's comparing to the PST condition in the original study I talked about with the 220 patients. And what we've been finding is that we're getting, by 4 weeks, we're getting outcomes as good as we got at 12 weeks with problem-solving therapy. And that it does level off over the 4 weeks, but that's just because we think they stop playing after 4 weeks. So there's a couple of interesting hypotheses there. Either they've reached their maximum training, and that's as far as they're going to go, or if they played a little more, like a couple more weeks, would we see continued improvement in their mood? So this is considered the farthest transfer you can see of, conditioning the brain and having a positive behavioral outcome. We also looked at this concept called near and far transfer. So people who study cognitive training, this is a big deal. It's not enough to show that you have improvement in the task that you're training in because, it's a practice effect, right? You have to demonstrate that it generalizes to either a similar task or a task that's in the same system, so in this case attention, but is a different kind of attention. And so I'll show you, this is data, our data compared to the study in the Nature paper, and the gold bar are our participants, and the blue bar are the older adults who trained in the original NeuroRacer study. And you see we're getting positive effects for near transfer, so basically it's another distraction task that they do. And we're getting really nice effects for far transfer. So this is a different kind of attentional system we're testing. It's the sustained attention system rather than selected attention. And so this is considered like the holy grail for cognitive training. So we're very enthusiastic, although it is a small sample and we need to keep going. So I'm going to talk about another intervention that we developed and are in the process of studying that is sort of a combination of looking at how neuroscience can inform treatment development, but at the same time taking into consideration the system of care that older adults are seen in. So in the United States, our training of professionals is highly variable. Some people are very, very well trained as clinicians. A lot of people aren't. We don't have any kind of uniform standard for how we train PhDs, master's level clinicians. It's very, school specific. For the most part, I would say that when people are trained in psychotherapy, for instance, it's mostly, they hook you up with patients. You come to a supervisor, you talk about how hard it was to do the therapy, and they say they're there, and it was hard for me too. But there's very rarely do you see any observational training, and so forth. Oops, my computer is jumping ahead of me. And so when we have been working with implementing problem-solving therapy in the community, I do this through the AIM Center at the University of Washington. I was very much struck over the years about how hard it was for clinicians to do PST very well. We also had another study. I had another study with Cornell where we were working with social workers who are in Meals on Wheels programs. And that was a really nice opportunity to really study drift over time. And even though we would train these social workers to the point that they should have been as good as our typical study therapists, we spent so many hours correcting them, listening to the subsequent, we've had independent raters listening to these audio tapes and calling us and saying, okay, this person's not doing PST. Did you give me the wrong tape to review? We'd go back, and it was really pretty painful, I think. So my colleagues and I started to think, maybe we need to simplify the interventions even further so that the typical clinician that works with an older adult can actually deliver the intervention to fidelity, and how can we do that so that it's actually an effective intervention? So we came up with this intervention called Engage. And so one of the first things we did was to look through all of our past therapist notes, problem-solving therapy, and see what were kind of the common first-step problems that a lot of the older patients came in with to solve. And we found that a majority of them focused on pleasant activities. So sometimes it was, engaging in activities that were to help them improve their health. Sometimes it was activities to minimize social isolation, but it was always some kind of behavioral activity that they focused on. And when we talked to some of the therapists who'd done PST in our studies, they basically said that some patients, that's all they needed. They kind of just needed a booster shot or something of getting out there and doing something different, and then they were able to solve problems pretty well on their own. But other patients were very difficult. Some of them had a strong negativity bias. Do you guys have Breaking Bad here yet? Okay, because it's funny in the States. Some patients, so these are the people who do action plans, and they would be successful, but then they'd come back and they'd be like, I should have done it a long time ago, or they'd focus on some negative aspect. Some of the patients would come in and they would not be able to do the action plans because they would be so, emotionally activated. They couldn't get started. And then others were highly disorganized, very executively impaired patients who, they're the kind of patients who come in, and if you've done behavioral interventions with them, they'll have a file with all the papers you've given them, and the papers are sticking out like this, and they spend 20 minutes looking for the homework form. So, obviously this starts to sound like CBT, right? And so we didn't want to reinvent CBT. If anything, we wanted to simplify it. And so we talked to the therapist and said, what are sort of the easy strategies that you came up with in doing PST with these patients to help them overcome these problems? And so, some of the therapists said, we focus on sort of helping patients to see, all aspects of the situation. So if they, some of the therapists had come up with strategies that their patients had developed, like practicing reading the newspaper and looking for one or two good news articles and focusing on that during the week. So very, very simple kind of strategies to help orient people's attention to positive as well as negative information. These were therapists in California, and mindfulness and yoga are very popular there. And so for the patients with affect regulation, they basically said the strategies that we use are things like mindfulness-based, like, focus on, deep breathing or some kind of, mindful activity. And then with the disorganized patients, it was really along the lines of things like case management or helping people, put environmental prompts, being very structured around if you have an action plan and you're going to get distracted, what are we going to do to prevent that distraction from happening? So we came up with the intervention. It's a step psychotherapy. It's 9 weeks of treatment, and it starts with social re-engagement. And you do that for a couple of sessions. It's very simple. You just basically say, what kind of things did you used to do that you're not doing now? Pick something, and let's just try it this week, see if that helps you. And if over the course of a couple of sessions they seem to be improving, that's all they do. That's all the therapist does. They keep doing the behavioral activation kind of stuff. But if they aren't getting better, then the therapist and the patient sort of talk together about, well, what do you think's getting in the way? The therapist can say things to the patient like, I notice sometimes when you, come back and talk about the action plan, you're only focusing on sort of the bad things that happened this week and not enough on some of the successes you've had. What do you think? What do you think we could do to help change that? And then if that works, you keep going with that. If that doesn't work, then you reassess and make sure you have the right, barrier to improvement. And obviously by 9 weeks, if they're not getting better, then they can move to a higher level of care. So the study we're doing, we're funded to do a non-inferiority trial, basically comparing engaged to problem-solving therapy. And we're looking at outcomes at 2, 6, and 12 months, so depression, functional outcomes. We're also collecting some data on some of the, reward behavior, behavioral activation, negativity bias, and so forth. But we're also really interested in assessing the time it takes to train therapists, comparing between the two interventions, and how many hours of corrective feedback they need over the course of the therapy. And so this is the pilot data that supported the grant proposal. These are depression outcomes over a course of 9 weeks with the Hamilton Depression Rating Scale. And we basically find that the two interventions are fairly comparable in terms of outcomes. And let me just do this because I think I accidentally turned on a timer. And this is skill drift over time from our pilot data. And basically you can see that the number of hours in corrective feedback that certified therapists needed in the engage arm, which is the blue arm, is far lower than what you see with problem-solving therapy. So, of course, we have to do the bigger trial. We're recruiting 300 participants and 16 therapists per site, so 32 therapists overall, to really test this. So let me just move on now to assessment, because it's really, it's a great idea, I think, to really come up with these targeted interventions, but they're not helpful if you don't know how to, identify the patients who need these therapies. And so as we're doing these trials, like the cognitive training trial and the engage trial, we're also simultaneously measuring the validity of mobile assessment tools. And so a couple that we're looking at are, some are, one app we're working with uses vocal features to measure change over time. So we're working with this group called SRI, and they're at Stanford. They're a big robotics company, but they're one of the investigators at SRI created Siri, and so they do a lot of vocal analysis work. We're also looking at, collecting activity data, so using the, Fitbits or, the accelerometer on smartphones. But most importantly, we're developing these cognitive assessment tools that can be delivered on iPads and should be, if they're valid and effective, should be relatively easy to distribute in a clinic. But we do have to consider things like burden. So just to give you an idea, this one tool we're looking at, there's a lot of things on these iPads that you can use to collect data. First, there's the gyrometer, and an iPad that helps you kind of see, how collect motor data from a patient. We also have a camera on these iPads that can collect eye tracking. They collect facial expression. Obviously, the microphone on the iPad collects speech behavior. And then the touch screen can get at fine motor assessment. But you can also collect data on, putting neuropsychological tasks on these iPads. The trick, though, is that you really need to make sure that, the iPad task isn't like a 3-hour thing, because it's a cumbersome way to do assessment. So we've been working with different kinds of algorithms. One is based on psychophysics, like a hearing test, where, you do, the algorithm starts at, different kinds of, it tries you at different thresholds, and then based on how you behave within the task, it can start to narrow down the range of your cognitive function, so you can collect this data a lot quicker. This is a different tool that we're using that's specifically collecting data on executive dysfunction. And usually, to do all these tasks, it would probably take about an hour to collect that information. It's pretty burdensome. But with this adaptive algorithm, it can actually only take 10 minutes, which is pretty exciting. However, the validity of the different tasks vary. The flanker task, which is this one right here, is not super. But, some of the other tasks, like the attentional tasks, are very good. And we're playing with different kinds of algorithms like adaptive design optimization or adaptive data optimization, which uses Bayesian models to refine the signal over time, so that we can have these assessments happen very quickly and theoretically very accurately. Okay, so basically in conclusion, the take-home message here is that we should be thinking about that behavioral interventions hold a particular value when it comes to targeted treatments. In some ways, we have a lot of really good candidate targeted treatments, more so than some of the pharmaceutical, agents are. We understand a lot of our behavioral interventions were developed through neuroscience. If you think about behavioral activation, it was based on a lot of animal research early on. So, Seligman's dog studies. I think there's some rat models as well. And so, when you think about like how some of the behavioral interventions were developed, we have some really good low-hanging fruit for potentially targeted intervention. So we've demonstrated that with executive dysfunction, we can actually target behavioral interventions to a specific population, but it's one population within a depressed group, and so there's a lot of opportunity to study different types of depression, get a better understanding of what treatments might be effective for, say, older adults with depression and affect regulation disabilities. And that, obviously we can see outcomes very quickly. In PST, it was as early as 6 weeks that we would see improvement in mood. With the game, it was 4 weeks. And so if you think about the burden of psychotherapy and how often, how much time it takes for a patient to come in and see a therapist. For us, it's 45 minutes. For them, it could be much as 2 hours, because they've got to drive in, they've got to see you, and they've got to get back home. So it's a big commitment. If we can make that experience shortened and streamlined, then we'd be doing them a big favor. So that's it.
Thank you very much for your talk. It's very quickly spoken, so I hope it will be understandable for the deaf people. But I think our cognitive control network is now working very hard, so maybe you can expect very difficult questions.
Okay.
Yes?
So the question was around motivation using the apps and dropout. So far, people have been sticking with they have been coming in. We haven't had any. Have we had any dropout? No, we haven't had any dropout. For most of the participants are playing the way they're supposed to. So it's 6 days a week for 20 minutes. We do get some variability. Some people can't quite do that much, but they seem to be okay, like continuing to advance in the game. So the game company is actually looking at the patterns of use and seeing if there's a way to streamline further the amount of time you need to train. They pick these times to train based on, they pick it out of the air. I talked to some of the people who do this work, and they're like, it's sort of an industry standard that it's 4 weeks for 20 minutes. It's a certain amount of time. But they've all said, nobody knows. You might need more, you might need less. And so that's still kind of an open question. Yeah. Yes.
Would it also be possible to couple back, like EEG data, like biofeedback data? Is it possible to include that in the app?
Yeah.
More that they use their brain well.
Right.
Is it possible?
So the question is, can you add, well, we call it a closed feedback loop. So can you use, attach an EEG to somebody's brain and have that data fed into the game? And that is definitely an idea that my colleagues who developed this game are working on. It's not, the complication is that EEG is very noisy data, and so to do a proper EEG experiment, you have to keep your head very still. And so even if you raise your eyebrows, woo, there goes the frontal lobes. So when you're doing this, it's hard to keep your head still, and so my colleagues are working with engineers who are helping to refine the signal, and it's hard. They're having a hard time, doing that. That's a good idea.
Yeah, it's very nice because we are currently working on it also here, but not on gaming, but on neurofeedback, and we have just the application to give neurofeedback with the EEG signal and reducing the noise is now working. In that way, they will demonstrate it now this Friday to me.
Oh, yay!
But the process was a little bit delayed. It should have already worked 3 months ago. So
you're ahead of the game.
It's very interesting, and I think you should couple it not only with the basic neurofeedback, but also with the gaming, and it will be more powerful, I think.
Right, right.
Other questions? Yes?
Maybe a bit of topic, but do you have any data on gaming addiction in the elderly?
I don't have any data on it, but I do have anecdotal data. We had one patient who got very hooked to the game, and he actually had an increase in depression when he had to give the iPad back. Yeah, and the therapist was a little bit worried about it because he spent so much time playing that she was worried he wasn't doing enough kind of external stuff. We do get a lot of, I would say not everybody, but many of the patients ask after they hand back the game, is there other things they could do to improve their cognition, because they really felt like they benefited from it, from sort of a self-report way. But yeah, gambling, addiction, that's a very big deal, and we have not looked at that yet. So we tell them, we can't let them keep the game because, we're not allowed to do that, but we say that there's a lot of games and things on the market, and we're very honest. We just say we really don't know how effective those tools are, but it's not going to hurt you. So if you really feel like you want to, sign up for Lumosity or Brain Age, or you want to do crossword puzzles, by all means, there's nothing wrong with it. So that's basically what we tell them. They do kind of push us a little bit, but but what should I do? And we basically say, I wish we could tell you, but anything, we say you should exercise too. Exercise is a really good, it feeds blood to the brain, which feeds oxygen to the brain, which is a very good thing for your brain. And so not all things that help with, what we call plasticity are necessarily psychomotor. They can, I guess exercise is psychomotor. So you can do exercise. It doesn't always have to be puzzles or those kind of challenging tools. Mm-hmm.
So what do you think the mechanism would be? Because it's improving cognition, but it's also improving the reward system.
Which is why we're measuring that.
Especially when it's addictive. So what would be the antidepressant mechanism?
Right. So in the scanner, for that study, we are looking at both cognitive control and the reward system. So one of the tasks in the scanner is this probabilistic reversal learning task, and it really kind of tests the degree to which somebody benefits from positive feedback. And so it's sort of and we think, there's probably something to it. The game is kind of cute, and it's a little boring over time because it really is the same task. It just gets more and more challenging, but it's something to do, and so it's like a pleasant activity. Yeah. So it's possible that that's happening as well.
Last question? No?
Oh,
Thank
that's
you
great.
very much for your wonderful presentation.